All right, guys, this is a continuation of 8.4. This is dividing rational expressions. It's really going to call on the skills that we learned when we were multiplying rational expressions. There's just one small difference, okay? So rational expressions is just a fancy way of saying fractions. Anything that's rational can be written as a fraction. So this is telling you that we're going to be dividing fractions. So let's do a quick dividing by fractions lesson here. Let's say we had something like this, okay? There really is no such thing as dividing by a fraction. Now, we had come up with a method to be able to do that. You've probably been using your calculator a lot throughout your life, and you've been dividing by a fraction. But let's try to remember how to divide by a fraction if you were never given a calculator, okay? I've heard ever since I've been here at Sycamore, there must be some middle school teacher that teaches that when you divide by a fraction, you keep, change, flip, okay? Now, that's a pretty elementary way of saying what we in math call multiply by the reciprocal, okay? To divide by any fraction, all you do is multiply by the reciprocal. The front fraction stays the same. And you multiply by reciprocal, or reciprocate means to flip. So again, let's go back to the middle school way for a second. Keep, I kept the first fraction. Change the division and multiplication. And flip. Now, when you multiply two fractions together, you just multiply straight across. Okay? So we're going to apply that to problems like we were doing yesterday, and you're going to know exactly what to do once you multiply by the reciprocal, or keep, change, flip. Just getting this problem written down. All right, you can pause the video now if you need to write the problem down as well. Okay, so basically what you want to tell yourself in your brain is you never want to do a division problem. Okay, so right now, the second I see division, I'm going to, first keep or rewrite the first problem, and then multiply by the reciprocal. Keep, change, and flip. And now this is a problem exactly like yesterday. So I factor, and then I cancel things out. Left numerator, I'm looking for two numbers that multiply to be 4, but add to be 5. That'd be x plus 4, x plus 1. Denominator, I'm looking for two numbers that multiply to be 12, but negative 12, but add to be positive 1. That'd be x plus 4 and x minus 3. This is a binomial, so it's either a GCF or a difference of squares. This one is definitely a GCF because 2 and 6 are not perfect squares. So the largest number that divides 2 and 6 is 2. I can also pull an x off of both of those things. Here I took the 2, I took an x, there's just an x left, minus. 6 divided by 2 is 3, and I took its x, so that's done. Here, this binomial is in fact a difference of squares. That's x plus 1, x minus 1. So let's see here. X plus 4, top and bottom. X minus 3, top and bottom. So I'm left with 2x, x plus 4, over x plus 1, x minus 1. And that'd be done. Okay? I think that's really all you need, as long as you learned what you needed to yesterday. So let's remember, keep, change, flip, or multiply by the reciprocal. Never do a division problem. Then factor and cancel, just like we learned yesterday. All right? Pretty easy, pretty straightforward. Keep plugging along, stay motivated. We're almost here at the end of the year.